Hello and welcome to this webinar in pre-stress. And today this presentation will be about the sloped I-beams and sloped TT beams in the program. I will model a couple of them, and I will make a few I will show a bit of the differences between a normal beam and or a normal hollow core. I will run this in the Swedish National Annex of Eurocode. It doesn't really matter because this function is valid for all the national annexes, and it is only available in version 6.5 and after. So if you have earlier versions like 6.3 and 6.4, they will not be available in those versions. So pre-stress. This is the main what I call the project manager, where we will have our elements stored, and you have most likely seen this before when you enter the sections and the toppings and so on. When we take a look at the sloped I-beams, for instance, and this is the beam that I will start with and go through the most, I will show a bit of a differences here, because and of course similarities. So here I enter the name of the beam, or as we say in Sweden, it's called littera. So I say that this is beam number 201, and the sloped beams and the sloped TT plates, we will not fill in the length or the section here. We will actually change the beam type from a constant section to a sloped I-beam. And this, as you can see here, we have the sloped T-beam and we have the variable rectangular section here as well. So this is the three options that we have when we don't have a constant section. And when I enter the sloped I-beams, I get a new button here called Configure. The Configure button, if I press that, we can enter the measurements of the sloped I-beams. And we have got requests to have more than one of these fields here, but in the current version we have, as you can see, one of these thinner areas here. So here you enter the length. I will use the default lengths for this presentation, but you can enter the length here. You can enter the different measurements, and if it is symmetrical, alongside the notch, or if it's not symmetrical, then you can enter the values here. If I would have said 190 in there, for instance. We enter the width of the cross section here in the start by changing the number to our left here, and the measurements of the I-beams we can take a look here in the section 1. And in section 1 we have the possibility to change all these measurements here. if we don't want to have it 480, let's say here in the section 1, then I could change the, let's say, the top value to 500. And this is also one version to make the sloped T-beams, but here in the sloped I section, or the SIB, as I will refer to it, we can have it equal here alongside the cross section. So this is section 1, and this will affect the part in the notch. We also have the section 2, which will be affected here in the out in the field between the notch and the support. And just to show that I can change this to, let's say, 120, or 100 is even better in this case, to see that we will have different widths of the web here. And it is possible for this kind of sloped beams to get a template or save this as a template if you want to make more beams, but you only want to change a few values. Instead of opening up a new file and making a new compilation of numbers, we can save the file, and yeah, if I say this as not a default SIB template, I will say that this is my SIB beam, and then I can make the calculation in the next time I make or enter a beam. I can go in and load a previous template here, and this is specific to the SIB and the STT beams because of the more measurements along the length here that we have. It is also possible to set as default if this is the default values for a lot of calculation that we will do, and we don't want to go in and change all these settings all the time. I will make this a little bit unsymmetrical here with the web length here, just to show that it is possible in the calculation. I press OK here, and now we have only made the in-data, the configuration of the beam. And if we want to add the beam, then I will start here with the add function, and this is similar to to all the other beams that we have. I will enter fire load combination here, just to show that we can have the fire loads here as well, and we can automatically generate dead loads and add the dead loads to a specific load case. And here I will say that we will have this in the dead load case. I will also enter a few other names here, because we might have snow on affecting this roof beam, and we might have the dead load of the roof here, but the dead load of the beam will be placed in the load case category here. It is possible to remove and add the dead load afterwards, and I will show that as well, that they are not only generated in this window, but it will actually be possible to add them and tweak them a little bit in the program as well. I will create supports automatically according to the current code settings, it says, but it is the similar way as we have in all the other beams here. And now it is quite similar to the previous calculations that you might have seen in other presentations or stuff like that. And yeah, so what I will do now is that I will make a calculation here, and what I will do is to add a little bit of reinforcement to this beam. Here we can see the beam, and it is possible to change the section where we actually see the slope and the cross section of the beam here. So before I actually start to enter the reinforcement, I will go through all the load combinations to see that we have set the specific environmental class and in order to get the correct concrete covers. So I will look in the release, and this is the general exposure class here. It is not really relevant because it has a 20-year life length here in the Swedish annex, and hopefully it will not be in the factory for 20 years. We have the concrete class here, which we can enter the value for the concrete class, and this is when it is detensioned in the factory. We go into the storage and maturing, and here we can see that the strength class is a little bit higher, into transportation and even a little bit more higher here, and the final is the construction site or the erection phase of the structure. Then we will have the final stage here of the concrete class that I have entered here, and this is the 28-day strength of the concrete. If we take a look at the intermediate stage and the final stages here, here the exposure class will be taking effect a little bit, so I will enter the another exposure class here as well, and yeah, I will go in and set it to XC1 for 50 years. This might seem a little bit tedious that we have to change it on all the settings here, but it is actually possible to change the exposure class along the life length of the beam here. But in this case we will have it similar all the way, and finally in the fire case here. So this is nothing particular special with the SIB beam, but I would like always to go through the materials here before I come to the I-beams here, and this is a little bit of a change from other normal constant sections. because we now will introduce an angle, so we can place the reinforcement in an angle alongside the inclination of the top here. And I will make it easy for myself, and I will just press the layer of reinforcement. And here in the top I will have diameter 16 with a cover of 30 millimeters according to the code, and in the bottom I will have the pre-stressing tendons. And if I say 2 bars in the top, we will see the bars here in the top, and they will be placed in the top alongside the whole beam here. And in the bottom I will enter something that I know will not be okay, so we will be able to change this afterwards, but I will enter 14 strands in the bottom here, and it will not be okay, but just to see what happens, and so it's not always perfect. What we can see here now is the normal, that we have the pre-stressing strands in the bottom and the strands in the top. We have the angle, and the angle is 0 for the ones in the bottom because they are going from start to end here. If I scroll down here, we can see that I have 2 bars from 0 to the notch with a positive angle of 1 divided by 16. And I will have the 2 bars from the notch to the end here. And they are not exactly half of the length here. You can see that they are actually 33 millimeters longer, and that is due to the inclination here, that they will be a little bit longer. We have the area, and they are not pre-stressed. And here we have something called full bond. For normal elements it will be set to at no side, which means that they will be not bonded in the ends. And this is the standard setting for hollow cores, for normal beams and so on. But in this case we actually have a possibility to change the bond, and for the first 2 here, row number 15 and 16, it will say that it is fully bonded at the right side, and the right side is up here in the notch, so it will not have the anchorage length calculated here. It will actually assume that it is fully anchored in the end here. And also the row number 17 and 18 is the reinforcement from the notch to the end, and they will be assumed to be fully anchored up here in the notch at the left side. And this is due to that you might want to add a reinforcement bar in the notch here, just to get it fully anchored. And I will show this in Paint. If I scroll in a little bit here, let's see if I can show my superior paint skills here. So what I mean here is that we have some kind of reinforcement bar in the notch here that is fully anchored, but it is bent in the top like this. So we will anchor the right bar with this kind of reinforcement bar. And that reinforcement bar you have to add when you're making the drawing. It will not be considered in this calculation here, because it's only for anchoring of the bars here. And we basically say that it is fully anchored in the right side and the left side. If we take a look at the stirrups, the stirrup here is a little bit different from also from a normal element. I will say that I have stirrups from the start point to the end point, but spacing 250. Well, I will say spacing 100, but I will only make it in the first 2.5 meters. And from 2.5 to 31,700. Then it became just perfect. 29,200, I mean. 29,200. There we go. And from 30 to 700, 31,700. We have 2.5 meters with spacing 100. As you can see here, we only use one leg per stirrup, and this is due to the thin web that we have. And if you want to have 2 legs per stirrup, then just increase the spacing here from 100 to 50, because the program is only looking at the group area here when it's making the calculation and when we're looking for the shear forces afterwards. So if it is, well, these values here in the left side, it's only to change the group area here in the right side. So it's not possible to change the legs per stirrup yet. This is something that we are currently looking on to be able to unlock, so you can have more legs per stirrup. But that will, or the thing that is making the most problem here is actually the way that we draw it. So it will only be a graphical issue at the moment, but the calculations are still correct. And if I go through the reinforcement details, and this is nothing particular new here, if we're using the Swedish National Annex for pre-stressed elements, the cotangents for theta is actually possible to set to 3.0 here. And this is a special Swedish requirement that has been inserted into Eurocode. But for all other countries that I know about, it is possible to have this as a maximum of 2.5. And we will be using the shear calculation using shear reinforcement. And we have a few differences here from the hollow core, for instance, that it's not possible to calculate the shear force according to EN 1168. So we have a few settings here that will be changed depending on what kind of cross-section that you have. The fire phase, I will say that we have fire from the bottom, but it's also possible to say that we have fire from the left side. But due to the geometry here, it will calculate fire from the right side as well. So it is, if you say that we have fire from the left side here, it is assumed that it will be able to be fire from the right side here as well. So now everything from the left side, the bottom and the right side will be affected. but the top side will be shielded from fire due to the roof. So in this setting I will use these 3 settings here, and I will increase the fire time to 60 minutes. The final tab is the calculation settings, or calculation sections, and here the blue sections, as we can see here, they are the sections that we must have in order to make the calculation, and these are used to make the dead load calculation and so on. And the black values here, they are the normal sections that is entered by default here. And if I press delete all here, for instance, I must keep the blue ones in order to make a calculation. But I will add a few more sections here. So I have spacing of 1.2, and we have the spacing here. It is recommended to have it between the section height and half of the section height. So between 0.9 and 1.78. For this case, it is the most recommended values. I will use 1.2 meters here just to have something in between here. If we take a look now at the material, we only have one thing left, and that is the long-term parameters. Here I will enter a creep factor, and this is what you have to do in the Eurocode when you calculate the creep depending on your beams. So do not just use my values here by default, but I will use a creep factor of 0.5 and then 1.5, and the shrinkage of 0.1 and 0.1. If you actually make the calculations according to Eurocode, and by calculation I will use the Eurocode, and I will show you the exact passage. It is these graphs here, and if you use these graphs in order to calculate the creep, then you are actually making a non-linear calculation by hand by just making these drawings. So if you see that the program or that the code asks that you have to be making a non-linear calculation of the creep and shrinkage, it's actually just following the steps in Eurocodes in order to, according to these formulas here, and you will have made a non-linear calculation. We are looking for a possibility to just enter the times, so you can specify the time here instead, and the program will actually calculate the creep and shrinkage for you automatically. This is something that I hope will be implemented during 2016, and I think that we have a good possibility to do so as well. So now I am actually done with the geometry, and I will move into the loads. So the loads are not specific to the SIB beam, so this will be very similar to the other bits and pieces here, but we can see the overview here that this is the dead load of our beam, that we can see the different values that is changing alongside the beam here. And if I want to go in and change it or add it or remove it or something, then I can go into each specific load combination, and now I removed the dead load for the release phase here. And if I want to add it, then I have just be able to press the self weight option here when I'm standing in a load combination, and it will calculate the values for me here, and I will just be able to press the beam and the program will add the dead load here. I will go through now the whole beam, and I will start with the roof, and the roof will be added in the erection phase, and let's say that I have 3.6 kilonewtons per meter worth of roof in the final stages. If I take a look at the snow load, I will add a snow load of 14 kilonewtons per meter, and this snow load I will assume will not be applied here in the erection phase, because you are still making the structure here, and they must have access to the roof and needs to shovel it off and so on. But when the construction is working afterwards in the maintenance phase, then I will just add the snow load here, and I just add it as a characteristic load here as well. So I have an overview of the snow load, the roof, and the dead load. Next step is to just go in and change the loads here. As for the transportation phase, it might be that you want to have some dynamic parameter or something like that, so I will just add 25% of the dead load as a dynamic addition to the dead load, so I get the dead load times 1.25 here. This is nothing that is stated in the code, but since you have some kind of dynamic response, you might want to at least add something here during the transportation phase. This will most likely not be the defining factor, but it is always nice to have this factor in the program. As for the intermediate stage, the short-term load, I will add 0.7 times the snow load, and I will use this, so I just copy paste it to the other short-term load here. And as for the long term, I will have 0.2 times the snow load here instead. And I will use that in the fire case as well. And in the ultimate limit states, I will have 1.35 times the dead load, 1.35 times the roof, and 1.5 times 0.7 times the snow load. If we take a look at the 610B, I will have another way to enter the values is 1.35 times 0.89, which is also a parameter specific to Sweden. Normal Eurocode has this to 0.85, and I will have the dead load and the roof, and I will have 1.5 times the snow load in this case. I have the original text down here, so if I uncheck this box, we can see that these formulas will change now, and the program will make it as short as possible to actually make the calculation of all the parameters to 1.20, 1.05 and so on out of these values here. And then I would say that I am done with the loads, and I will make a calculation. And yeah, I skipped the second order analysis for this section, and apparently I have used invalid cover. The Eurocode says that I need 29, but I have entered 28, but yeah, I will use that anyway. So we have done the calculation. I thought it was, yeah, we're still on the fire phase here. We can see the moments and the shear forces. It is not possible to have the axial force here, because this axial force, it's 0 in these cases. It's actually an outside axial force, and the pre-stressing, it's not considered as an external force, so it's an internal force, and it will not be shown here in the analysis. And we have the deflection, and we can see that we have different, or two values here. We have the x and the y value. The y value, if we take and zoom in the one case here, this is the camber in this case, or negative deflection, while this minus 2.7 is that the beam has been shortened 2.7 millimeters here in the notch, and the total value here in the end will be 5.4 millimeters that this support has been moving inwards here. If we take a look at the erection phase, for instance, we can see that we have both deflection and camber, and all these values alongside here will be shown when we take a look in the design and look at the results there. If we take a look at the intermediate stage, we have 189 millimeters of deflection in this beam, and it's quite a lot, but the beam is, after all, 34 meters long, so but yeah, the program has a possibility to make a check for deflections as well. So I will make a design calculation here as well, and make a code control, and now I will not get it to work fully, basically because yeah, as we can see here in the final stages, we have a lot of problems. If I go into the results and take a look at the code check to see what the code says, we have a few others here as well. So we have the compression stress here, and it says that in the storage and maturing we have a too high compression stress. We have to deal with that. And I will go back and see what I can make about it. We have the transportation, it was okay. Intermediate stage, here the stress after release is a little bit too high, and in the ultimate limit states we have problems with moment capacity, and yeah, we are lacking 45% here, and shear capacity we don't have enough with stirrups. And in the fire case, yeah, we have a problem with moment capacity here as well. So we have a problem with moment capacity and the shear. And in order to manage the shear reinforcement the easiest, we go into the ultimate limit state. We take a look here in the requirement, and we can see that this is what we currently have, and this is the requirement, and this is the minimum reinforcement that we need to have. And we can see that we have a lack of reinforcement here. We need 486, 484, and this is depending on the width and the height, these values. So we need to have it for at least 3.7 meters, the current, let's say 4 meters from each side here. So I go back to input geometry, and this is quite similar to any other here, that I will just add 8, let's say 8 bars there. Then it didn't update, so I will remove the bars here for some mysterious instance, and I will add more reinforcement bars here. There we go, and I would get an error because I don't have anything selected there. The layer reinforcement, I will add 2 in the top and 8 bars here. I will go into the stirrup reinforcement and extend this to 4 meters. We get a red value here because they are overlapping each other. And this should be 26,200, and from 30,200 with a length of 4 meters, we would have the stirrups, and I can make a new calculation. Before I do that though, we had problems in the storage and maturing, and I want to use a clause here in the Eurocode: prevention of longitudinal cracks can be avoided, and this is that you need some visual check just on the construction yard, or in the storage yard, just to see that we don't have any longitudinal cracks. And I make a new calculation, and this will, still 28 millimeters instead of 29. We will still have problems though, because we have introduced more reinforcement bars here. So the analysis looks decent, and we check the code control here, and it is better but still not perfect here, so I might have needed one more round here. And we can see that I still have problems with compression stress, even though I use 0.7 instead of 0.45 now. So in order to avoid this, you can lower the pre-stressing force without actually changing the moment capacity here in the final stage. And we take a look here in the final stage. This is pretty decent now in this load combination, but it's not really good here, so I might want to add just a few more stirrups and change so I get just a few more bars in the bottom as well. What you can do to solve both these problems is that you add a non-tensioned let's say diameter 16 bar or 25 bar in the bottom, because then you will improve the load combination here and you will actually reduce the compression stress in the section in the early stages, because this very thick reinforcement bar will take the compressive stresses and help with that as well. So there are no specific yeah, we can just see the fire case here as well. This is in the first stage here, and if we take a further look upside the beam, we can see the how the fire is affecting the cross section here. And yeah, see in mid-span, for instance, where we have the dashed line, and everything that is outside the dashed line will not be included in the calculation. It's assumed to be damaged, and if there would be any reinforcement bars outside the damaged zone, they will not be included in the fire calculation. I will go back to the geometry, and I will start with taking a look at the sloped TT beams here instead. And in this case, I say that I have another name. I change the sloped T-beams and I press configure. And this value here, or this TT beams, it's actually a template that we've used from Strängbetong. So this is their particular beams, but it can be used if you want to have like a flat section here in the end, or if you don't want it. And you can see the sections down here as well. If you want to change the section, you press the 1 section here, and it's possible to change all the different settings here. I know that a few companies, they have this waffle pattern, as can be seen in the bottom here. I'm not sure if I have a picture of that particular waffle pattern, but it is made in order to reduce the dead load of the upper flange here. And we don't have the inclination of webs either here, because they are symmetrical, then the forces will actually be negating each other. So what we do here is that we calculate on one T-beam that has not this inclined leg here. And you can change all the numbers, as can be seen here. The height of the cross section, it will not be defined here. Here you will only be defining the top flange and the bottom flange and the width of the flanges and the web. The top or the height of the web here, it will be defined from the maximum height in the left part, as can be seen here. And for this case, it's also possible to save this template. If you have a specific length, then I might say that, yeah, for the beam data here, I have my STT project 1 beam, and I can save it, and it's possible to also load this template with all these values if I want to have it calculated. And as similar with the SIB beam, we have the symmetrical possibility here as well. If you want to have a lot of these STT, it is also possible to save as default. So this is very similar to the SIB beams or SIB beams. We have made the configuration of this slab, and this is the old one. So I just press add, and in this case, since I already have a previous beam, I can go in and change to set the generate dead loads automatic in the dead load combination, and I will have my T beam here, and we can see the cross section here, and here you can see in the end what is changing is the height of the top flange. If I move this back and forwards alongside the edge here, and then it goes up and down again. So the inclination of the bottom side here is equal alongside the whole length, but it's only the top that will be thicker here in the ends. And with the layer reinforcement, it's very similar here, that I maybe not want any bigger reinforcement. I will add 1 bar in the top, diameter 20, and in the bottom I will have, yeah, due to the cover, it will complain that I will only be able to have 2, but if I go in and tweak this a little bit, I should be able to set 3, 3 and 2, and I want my 1 in the top, and here this will be presented. It didn't really like the 1 in the top, maybe due to low parts here, but let's see if I can squeeze 1 in anyway. Yep. So what we don't do with the T-beams here is that we don't calculate the shear force between the web and the flange up here. That might be something that the Eurocode says for specific for T-beams, but for these kind of elements we do not make the shear calculation up here in the cross section. As for the stirrups, this is the same as for the SIB beams. I have also 1 leg per stirrup alongside here, and let's see if I can, yeah, as you can see, it's only, it's not possible to show it on this particular, maybe if I can find one here. This is only one leg of the stirrup that goes down here, and you might want to have, if the web is usually quite thin here, so it's not possible to have several legs per stirrup here in the cross-section plane, but it is possible to have it alongside the other. But in this case, the spacing of the stirrups, if they are have like one leg here and then they are bent up backwards behind the other here, and if they have a spacing of 250, we might want to add to 125, so we have the correct group area here as well, with the square millimeter per meter. And otherwise this will be very similar to the SIB, I have a little bit of fire for this one as well, on the right side and left side and in the bottom, so I would have a fire case for this beam or element, I would say here. And otherwise it is very similar to the sloped I-beams that I will have here. So I will just go in and make a quick calculation, and there are no specific results that are only for the SIB and the STT beams. It's only the geometry part here in the beginning that is unique to these elements here. So if you have any questions, then you can enter it in the chat and I will try to answer them as good as I can now when you have the chance here. I got a request from an earlier webinar to make one similar for hollow cores and the specific hollow core elements, and I will do that either later today or in the beginning of next week. So there will be a special hollow core, not webinar session, but just a similar presentation as we have had now, but for hollow cores. So if you have questions on that, then they might be answered in that session. And we also now have introduced something that I would like to promote a little bit, and that is our forums. So we now have a StruSoft forum that it can be reached from www.strusoft.com/forum, and here it's just released, so we don't have that much interaction yet. So this is, I think, I entered, or we launched it 26th of November, so we're currently in the promotion phase here now, and we have a special section for pre-stress, and here I will post announcements, release notes, known issues that we have. We have geometry, loads, and different results. If you have different license questions, it will be here, and if you have user requests that you want to add in the program, it is possible to add them here. And we had a Swedish user that wanted some requests here, so we posted it in Swedish, but I would recommend to keep it in English as much as possible. And if you Estonian guys want to write in Estonian, then Stojan will have to translate it for me, or that he might go in and answer as well, but keep it in English here as much as possible would be much appreciated. And this is for the users as well, so the more information that you enter here in the forums when you are registered, the better the forums will be as well. So yeah, if you have questions here, then you can post it here, and I will also post this on YouTube as well. So if you post some comments in the YouTube field there, I would hopefully I will be able to catch them, even though that the forums is a much quicker way in order to make questions. And of course you can mail me directly or use the support mail, which is preferred as well, because I am most likely out traveling and holding courses and so on, so I might not be able to answer all your questions directly. So yeah, if you don't have any questions, we could end today's webinar here, but if you have any questions, then you can post it in the chat window here that we have, and I will be happy to answer them. Otherwise, I will wish you a very good day and a nice weekend, and hope that you get a better weekend than we have here in Gothenburg. Yep, thank you. And yeah, you might not have any questions now, but if you have questions during the weekend or something, you're free to contact me here as well. Yeah, have a good day.